Okay, so now I want to prove this fact that we have here, that if the limit of the AK sequence is equal to L, then the liminf and the limsup are also both equal to L. So let me get about proving this. So let epsilon be greater than 0, and we want to choose n so large that AK minus L is less than epsilon for all K greater than N. And let me do a little scratch work in the next couple of pages. Let me advance the slideshow a couple of pages to show you where I'm going with this. So we know that AK minus L is less than epsilon, and this is the same as saying L minus epsilon is less than AK, and this is less than L plus epsilon. If you're wondering how to go from there to there, pause the video for a moment and think about it. This inequality is the same as saying minus epsilon is less than AK minus L is less than epsilon. But if you need to think about that, feel free. And in fact, I encourage you, I'm telling you, pause the video and think about it. Okay, so this inequality is true for all K greater than N. So this is going to be for all K greater than N. In other words, if I look at the set AL, where L is greater than N, okay, then L plus epsilon is going to be an upper bound for this set, because this inequality is true whenever K is bigger than N. And this set consists only of AL, where L is bigger than N. So if AL is in this set, then it's less than L plus epsilon. So L plus epsilon is an upper bound for this set. L minus epsilon, similarly, is going to be a lower bound for this set, because we're saying as long as K is bigger than N, AK is bigger than L minus epsilon. So L minus epsilon is a lower bound for this set. Now, UK is the infimum. In particular, it is the greatest lower bound. Since L minus epsilon is a lower bound, this is true. We know L minus epsilon is less than or equal to UK. Over here, less than or equal to UN. UN is the infimum of this set, by definition of UN. Similarly, Vn is the supremum of this set. It is the least upper bound. L plus epsilon is an upper bound, so this is less than or equal to L plus epsilon. Okay, so it's saying that the least upper bound, the supremum, has to be less than or equal to the limit plus epsilon. So again, this is the pulling down. The Vn is going to be less than or equal to L plus epsilon. And as epsilon gets smaller and smaller and smaller, that's going to get closer and closer and closer. It's going to pull, this sequence is going to pull the Vn down closer and closer. And something similar for the Un. Okay, so now we're going to make the next observation. Un is an increasing sequence. So this means that Un is less than or equal to the liminf, which we call U. The liminf is always less than or equal to the limsup. Let me explain why this is on the next slide. And then the Vn sequence is a decreasing sequence. So V is always going to be less than or equal to Vn. So we have this inequality here. And let me explain why U is less than or equal to V. So U is equal to the limit of the Un. V is equal to the limit of the Vn. Now for every n, Un is less than or equal to Vn. So it means the limit of the Un is going to be less than or equal to the limit of the Vn. This is equal to V, and that's equal to U. Again, the limit of the sequence of lower bounds is going to be less than or equal to the limit of the sequence of upper bounds. Okay, again, that's one of these facts that's obvious, but that you might have to think about for a while. So again, feel free to pause the video if you need to. Okay, so overall, what this inequality is going to tell us is that L minus epsilon is less than or equal to U, is less than or equal to V, less than or equal to L plus epsilon. And now the idea is that this is true for every this is true for every epsilon greater than 0. And so really we have equality everywhere here. So L is equal to U is equal to V is equal to epsilon. Okay, so let me use this here to wrap up the proof over here. Okay, this is true for all K greater than N. Then L minus epsilon is less than AK is less than L plus epsilon for all K greater than N. That is, L plus epsilon is an upper bound and L minus epsilon is a lower bound for the set AL. Sorry, again, my pad here is not writing every time I write. Okay, so L minus epsilon is a lower bound, L plus epsilon is an upper bound for this set. Then UN is greater than or equal to L minus epsilon, and VN is less than or equal to L plus epsilon. Again, that's because UN is the greatest lower bound, VN is the least upper bound. Since the UN sequence is increasing, this means UN is less than or equal to U, and VN is decreasing, so V is less than or equal to Vn. Also, since UN is less than or equal to Vn for all N, U is less than or equal to V. So putting this all together, putting all of these inequalities together, we have L minus epsilon is less than or equal to UN, is less than or equal to U, is less than or equal to V, is less than or equal to Vn, is less than or equal to L plus epsilon. Or we can deduce L minus epsilon is less than or equal to U, is less than or equal to V, is less than or equal to L plus epsilon. Okay, now this is true for every epsilon. So if it's true for every epsilon greater than 0, this is true for every epsilon greater than 0. This is true. Epsilon greater than 0 is arbitrary, so this is true for every epsilon greater than 0. There's a number of ways we can finish the proof here. The way that I'm going to do it is to break this inequality into two pieces here, and say that L minus epsilon is less than or equal to U, is less than or equal to L plus epsilon, and also L minus epsilon is less than or equal to U. This is less than or equal to L plus epsilon. But both of these inequalities are the same as saying U minus L is less than epsilon. I guess less than or equal to epsilon. And this one should be a V. And L minus, come on now, L minus V is less than or equal to epsilon. Okay, and again, this is true for every epsilon. So this tells us U minus L, the absolute value of U minus L is equal to 0, and the absolute value of V minus L is equal to 0. So U equals L and V equals L. The main thing, so that's the end of the proof. The main thing is getting to an inequality like this, and really the main idea here is to recognize that UN is going to be, that L minus epsilon is going to be less than or equal to UN, UN is less than or equal to Vn, and Vn is less than or equal to L plus epsilon, so that the UN and the Vn are squeezed between L minus epsilon and L plus epsilon. And so as epsilon goes to 0, we have this squeezing going on. Okay, once you kind of figure that point out, there's many different ways to finish the argument. That is sort of the key to the proof here, is realizing that Vn is going to be less than or equal to L plus epsilon, and Un is going to be less than, or going to be greater than or equal to L minus epsilon, and then we have this going on. Okay, so if that didn't make sense, watch this video again, read the book, think about it yourself until it does make sense.